So question to ask us for two things, which is the lowest fuel cost, the speed that will give us the lowest fuel cost, and the lowest total cost. So we're here to minimize the fuel cost. So to minimize the fuel cost, first we need to get the fuel cost equation. So we know that fuel cost equation is equals to the number of liters times the cost per liter. So in the question, we're given an expression for liters per kilometer, which is 1 over 400 times 4,900 over x plus x. So, and we also given the trip, which is 200 kilometers. So to get the number of liters, the total number of liters, we need to multiply the expression, which will give us like liters per kilometer, and multiply it by 200 kilometers. So this will give us the number of liters. Then we multiply it by the cost per liter, which is 0.45. And that will give us the equation, and this will give us the equation for fuel cost. So 0.45, which is the cost per liter, times 200, which is the trip, kilometers, times the expression for liters per kilometer. So we can simplify this more. So here 0.45 times 200 is 90 times 1 over 400 times 4,900 over x plus x. So as I've said, we're trying to optimize the fuel cost. So we can also simplify it more. So it will equal to 9 over 40. If we multiply 90 times 1 over 400, we're getting 9 over 40 times 4,900 over x plus x. We also can distribute the 9 over 40 here. So we're going to get 2205 over 2 over x. 2 multiply x, sorry, plus 9x over 40. So this is the equation. So to optimize the fuel cost, we need to get the derivative, and the derivative we're getting, we need it equal to 0. So letting it equal to 0 will give us the critical points, or when the slope equals 0. So then after that, we need to check if it's a min or a max. So to get the derivative for fuel cost, we first can simplify this more so it's easier for us to work. So we can move the x up. So as we know from the exponent rules, if we move the x up, it will have like a negative power. So f is equal to, so this expression, this equation I'm getting is equal to this equation. So, but we like rearranged it. So 2205 times x to the negative 1 over 2 plus 9x over 40. So we can take from the derivative rules, we can take this out, and from the derivative rules, when we get the derivative for a power here, we need to take the power and move it down, then minus it by 1. So let me show you. So f prime here, will equal to, here we can move it 2205 over 2 times, if we move here the negative 1 down, we're getting negative 1 times x to the power of negative 2. So I negative 2, negative 1 minus 1. So it's from the derivative rules, and minus 1 for the exponent. So negative 1 minus negative 1 will get negative 2. Plus, we can do the same thing, move the 9 for same thing for here. So 9 over 40, move it outside. So we're getting 9 over 40. So here, and we move the 1 down, and we do n minus 1. So 1 minus 1 will give us 0. So x to the power of 0 is 1. So this is the equation. So we can simplify it more. So I will rearrange the equation. So 2205 will give us times negative 1 will give us negative 2205 over 2. So we can move the x to the power of negative 2 down, as we know from the exponent rules, plus 9 over 40. So this is the derivative. Now we need to get we need to make the derivative equal to 0, which will give us the critical values, or when the slope is 0. So 0 is equal to negative 2205 over 2x squared plus negative 2205 over 2x squared plus 90 over 40. So we can move this to the other side, so it becomes positive. So here 2205 over 2x squared equals 9 over 40. So now we can cross multiply. So we're going to get 2x squared times 9 is equal to 2205 times 40. We can divide both sides by 9, so we can get rid of this 9. So 2x squared is equal to 2205 times 40 over 9. So using the calculator, if we use the calculator here, 2205 times 40 over 9, we're going to get 9,800. So I'm going to go up here. 1 minute. I'm going to go up. I need to go up a little bit. So here we're going up. From here we're going up here. So 9,800 over is equal to 2x squared. We can divide over 2 over 2. X squared is equal to, so 9,800 over 2 is 4,000. Here 4,900. So if we square root here, x is equal to plus or minus, or 4,900 is 70, plus or minus 70. And we have the domain, which is 30, is between x between 30 and 120. So negative here is not acceptable. So x is equal to 70, and we know x is the kilometers per hour, so 70 kilometers per hour. So now we're going to check if it's a minimum or a maximum using the first derivative test. So the first derivative test is to get a number before 70 and after the 70, and if it's a minimum, we're going to get a negative before it and a positive after it. So it's like this, it's like decreasing, then here's 70, so 0, then increasing. So this is a minimum. So if we get something like this, it's a minimum. If we get like positive or positive here and negative there, it's a max. If we get like negative or negative or positive, it's neither. So let's check now. So the equation, we have it here for the f prime, 2205 over 2x squared plus 90 over 40. So if we take a number before 70 and a number after 70, let's for example take 69, f prime of 69 and f prime of 71. So if I use my calculator here and use the equation of the derivative there, so 2205 times 269 squared plus 9 over 40, we're going to get a so here I got a value for 69 to be negative, so it's negative number, it's a very small number. And so let's take now 71 here, so change the x to 71. So we're going to get a positive number. So it was decreasing until it reached 70, so then increasing. So 70 is a minimum, so we checked, so 70 is a minimum. So the speed that will result in the lowest fuel cost is 70 kilometers per hour. So therefore the speed that result in lowest fuel cost is 70 kilometers per hour. So now we need to get the lowest total cost. So we need to check the two endpoints, which is 30 and 120, in the equation for the fuel cost equation. So I've said before that the total cost equation is the same as the fuel cost equation because we only have one cost, which is fuel cost. So the total cost is equal to the fuel cost equation. The total cost equation is equal to the fuel cost equation. So to get the lowest total cost, we need to check both endpoints, which is 30 and 120. So we know that the fuel cost equation is equal to the total cost. So T of 30 and T of 70, which is the speed here, the speeds, and T of 120. So the lowest one will give us the lowest cost. So T of 30, if you plug it into the equation of the fuel cost, which is the same as total cost, which is here, 2205 over 2x plus 90 times x over 40. So 2205 over 2 times 30 plus here 9 times 30 over 40. We're going to get 43. For 30, we're going to get 43.5. So what about 70? 70 would give us 331.5. So we're given, so this is in dollars. So here it's in dollars. So 120. Also, let's check 120. We're going to get $36. So the lowest cost is $31.5 or 3150, I think so. 3150 cents. So therefore the lowest total cost is equal to $31.50. So that's how to solve this equation. Thanks. So here's the answer, and this is the second answer.